Welcome. This episode is about scatter plots. I'm going to look at the very simplest forms of scatter plots that just use two variables. This is numerical data, and it'll also be ratio scale data. So here's a scatter plot. You'll see a number of things about it. One is that it has something I've labeled here independent variable. So this is usually a problem domain given variable, and in this case it's just the alphabetic rank of letters, so from A to Z, their number from 0 to 25 in the alphabet. And then vertically, very often there's a dependent variable, and in this case that's a frequency of a letter. So that's a percentage in this case of the letter in its occurrence in the English alphabet. There's all sorts of reasons why you might want to know that. Code breaking is one of them. A frequency of letters can lead you to the frequency of code symbols, which can lead you to unpick what a code means. But today's example is going to be language classification. We're going to look at how different proportions of letter frequencies allow us to distinguish between, for example, English and Finnish or English and German as languages. So let's look at some code. We'll just go into Jupyter. Here's the setup code, as always. So that's loaded in the libraries that we need. We're going to read in a frequency table. And this table gives us, in fact, if you look at the table, we download and look at it, it gives you all of the frequencies for all of the letters in all of a number of European languages. And we're going to choose to use Finnish as a language here. And we're going to do a couple of things to that, so that we've got the data we need to plot. We're going to extract from the frequency table just the language itself. And then, just for the sake of keeping these plots small, we're going to extract out just the first 26 characters in the alphabet. So we're going to leave out any non-English characters above row 25. If you're doing this in reality, and in fact you'll see the software later running, it uses more than just the 26 letters to classify languages, which helps a lot because some languages with accents or cedillas or umlauts are a lot easier to classify. So the first thing we're going to do is just generate an index for this data. So this index is going to be an alpha order and a plot order, and they're going to be the same to start with, and we'll see later on that the alpha order and the plot order will change a little bit. And then in addition to that, we'll start to plot things. So I will copy in these lines. So this is a plot call. It sets up some axes for us. It sets the aspect ratio to equal. You remember that means that there's equal pixels for equal unit intervals on the vertical and horizontal axes. And we're going to use a scatter plot call. I'm going to plot it by the index and the frequency. And then we just simply plot the index versus the frequency. And this gives us a base plot where there's a frequency value for every letter in the alphabet. You'll notice it's not labeled, and there's no titles, and there's no labels on the axes, so we'll fix those things now. So here's the axes labels. Okay, we've got that. Now we want to put the letter labels near each point on here. Now that's a little bit more tricky. So for each row in the frequency table, we extract from it the row itself, and we extract from the row the letter of the row, its position in the plot order, and its frequency value. And then we add a little bit to each of these. So we're going to put labels slightly to the right and a little bit above each of the dots we've just plotted. And if that works, there we go. We get the dots and the letters related to them at the same time on the plot. In Matplotlib, you can change the glyphs, like the dots can be squares or crosses or a number of other symbols. So this is all very good, but this isn't plotted in any particular order other than the alphabetical order. And we might want to know, for example, whereas Q, is Q between W, X and Z, above it or below it? It's quite tricky to see visually, but if we sorted these, then that would help us define that. So here's what I'm going to do to sort them. I'm going to call sort values, sort by frequency, so it's going to sort in the order. I'm going to send it from largest to smallest, ascending is false. I need to reset the index, and I've done that so that the index will otherwise be shuffled around, and then set the plot order to be the same as the index, so that the order in which we plot the symbols is the order we've sorted in and not the original alphabetical order in the data. Okay, so we'll run this. and then we'll rerun our plot. And now we've got that sorted order. So by resorting it and making sure we plot in the sorted order, we can easily see that Q in fact has the lowest value here in the Finnish alphabet. Now, what happens when you want to compare scatterplots? Well, here's the scatterplot for the English language and the Finnish language, and it's only up to the first 26 characters, you'll see again. And you'll notice there's a significant difference. So for example, in English, I's and H's have about the same frequency. In Finnish, there's a very big difference between I's and H's. So it's that kind of difference that allows us to do comparisons that identify whether a piece of text is written in a particular language or not. So once we've got these frequency counts, we can use them to calculate a probability that a particular text is in a particular language. And on the left is Arthur Ansom's Spring from the Child's Book of the Seasons. And you'll see that the highest probability, so the lowest errors between the frequency count and the frequency in this text are with English. And on the right, there's a Finnish text by Thomas Kurge. And I'm not going to even pronounce the title and the chapter name there. But you'll see that, again, the most likely language, the one with the least error difference between what the letter distribution here and in the overall frequency chart, is Finnish, by a long way in both cases. So simply by counting the number of letters in generic text in the language and then coming back and counting them in a specific text, you can get these error plots. This type of training, which is what we're doing, we're training a model, and the model is modeling the language based on a particular assumption that the frequency of letters can uniquely identify a language, and then testing a classification of a text is almost exactly what most machine learning systems really do. They will take a frequency of something and they will test an incoming data set against that frequency and give you a probability of which of the outputs is most likely. Okay, so this is going to be a brief demonstration of the language identifying code. Okay, so here's some code. It's from Adrianus Clemens, and you can find it on GitHub, and there's a copy with a slightly cleaned up letter frequency table, adding the English language to it with the course. So let's go to the very end. What happens is we call analyze on snippets, which is the list of text files. And in this case, we're just giving it an Arthur Ansom text, which is in the English language. And it goes through and calculates an error difference between the frequency of the letters in the text we've given it and the frequency of letters in the frequency table for each of the 12 languages. The language that has the least error difference between frequencies is the one which we assume is the language of the text, the snippet we've been trying to test. This software doesn't calculate the original frequency table, but that you can do with the same software quite easily by going through and processing large numbers of texts. So if I run this, you'll see it's giving an output here. So this is the plots. This is the score for the ransom text. This is the most likely text in it. And we look down, we should find in this list, English has got the most points by a long way in this, and it's the least error and the most points. Therefore, that's the one that the software is classifying as most likely here as the outcome. Okay, so that's a brief overview of this running software.